16 and 17.
16, 17. Okay.
It's
Okay. Yes. All right. Thank you. All right, guys.
If you see aldehyde.
What type of this reaction?
So what's important?
Can I? Okay. Should I remind you? Like primary alcohol oxidizes in 2 steps: aldehyde, carboxylic acid. Secondary alcohol, just 1 step to what? To ketone. Tertiary alcohol, no oxidation, right? Okay. What type of this reaction? CH3, CH2OH, alcohol, to alkene. Yeah.
Yeah, I just have, I don't know.
Taking what?
Taking out what?
Water. Taking out water. What do you mean? Dehydration. Yeah, dehydration.
So when is it called condensation? When is it special?
Condensation as well.
Oh.
Yeah. Dehydration.
Dehydration is the same as condensation.
Yes.
Dehydration is just specific to.
Yeah. Condensation taking HCl, HBr, H2O in general, but dehydration specifically for water. Okay. What type of this reaction? Alkene to bromoalkene.
Oh, substitution.
Yes, that's right. Substitution. Substitution, that's right. We took hydrogen, replaced it with what? With bromine. Just substitution. It was CH3, CH3. It became CH3, CH2 instead of 3. And instead of the third hydrogen, we added Br. So substitution. Okay. Or we call it depends on the options, if it's multiple choice. We can call it as well halogenation.
Oh, halogenation.
Halogenation. Adding halogen. Okay. Br is a halogen, right?
Yeah.
Fluorine, chlorine, bromine, iodine. They are halogens, right? Halogenation.
Yeah.
Okay. Can we call it bromination? Specifically for this?
No.
Why not? Why not? Okay. But it's okay. What type of this reaction? See, alkene to alkane. Addition in general, or in this case specifically is
Hydrogen.
yes, hydrogenation. The 3p atomic orbital has the shape of
That's alkene.
yes.
Dumbbell. That's not so 20 permits alcohol is oxidized.
What is it? It's like this, okay? Or infinity, or dumbbell, oracle, okay?
That's sigma.
But Mr. Glock, 3P is alkene, right?
Yes, that's.
What's that?
3P, like 3P shape. Is that alkene?
No, P is atomic orbital.
Well, atomic, okay.
Any atom. Okay. So number. Okay.
That's the word is not becoming alcohol.
The 3s atomic orbital
Aldehyde or carboxylic acid.
has shape of what?
Yes.
Spherical. Okay.
Spherical.
Yeah, spherical. S is spherical shape.
Oh.
Go back to your notes. Go back to your the PowerPoint. You will see them. Okay. A region of space in which oh yeah, a region of space. Children, tell me what's wrong? Lost. That's why I called you.
Mr. Bilal, just waiting.
Yeah.
So can you broadcast your stuff to Teams?
Podcast.
Like what on the
No worries.
no, not late.
Who you're broadcasting?
It is recorded.
Oh,
By-
recording.
Yeah, by Mr. Favor.
Favor. Who's Favor?
Okay, so you can watch the videos.
Oh, we are your streams. I don't think I know.
You mean Favor?
I was.
Oh, no. But,
I am.
okay, Favor can share this with you, okay? Favor, do you hear me?
Yes.
Yes, sir. Yes, sir.
Yeah, share the video with the students, please, okay?
Okay.
Yeah.
Okay.
All right.
I can put it on. I'm not.
What?
Is there a group where I can put it in?
That's 1.8. So 1.8 meters is exactly here.
Who's that?
Now I've got my coordinates, I can find that.
No, that's
Okay.
Oh, yeah.
Whatever. It will be on the chat. Yes. So, okay. Okay. I'll take care of that. Okay. I'll take care of that. Don't worry. Okay. Let's continue. A region of a space in which there is a high responsibility, high probability of finding an electron. The definition of what? Region of space.
Orbits. Is it orbit?
Orbit.
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 Okay.
So, isn't there density? Remember, there was density in that one.
Yeah, it's the yeah. That's right. Same idea. Same idea, Osama. The most density of the electron cloud.
I remember.
Something like, but I mean the same idea. Region of space in which there is a high probability to find the electron. Okay, it's the orbit. Write the electron configuration for oxygen ion O-2 and chromium ion Cr+2. Electron configuration means what?
1 is 2.
1 is 2.
O2 minus means it has 2 extra.
That's why I just bring this up actually,
Yeah.
because I need to know how to deal with the ion. So oxygen from the periodic table is the atomic number is 8,
Yes.
right? So when you write the electron configuration for 8, 1 is 2, 2 is 2, 2p, 4,
4.
right? Oxygen,
So
just hold a second, hold on. 1 is 2, 2 is 2, 2p4, right? When it's minus 2,
we added, that's now 2p.
adding 2 electrons, this means
2p is 6.
okay? Chromium plus 2,
Lost 2.
chromium plus 2. Chromium is 24, right? 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6. No, sorry. Three P6, 4 is 2, 20, 3D, 4, right?
3d4.
For now. Now, chromium, what's special for chromium? If it's chromium, just chromium, I'm gonna keep it like to see that. Chromium, what's special about chromium?
Cancel 1.
Yes, half filled. So the S becomes 1 and the D becomes 5. Chromium 2 plus. You will do the same here, okay, same. 4 is 1, 3d5. When it's plus 2, the electrons should be
And this one.
from 4s. So I will keep 3d4. The electrons, one from the S and one from the D5, to leave it as D4. Okay? Yes? One from the S for S1 and one from the D5 to become D4, right? Okay, so here, this is missing, this one, and one electron from the D5, it became D4, okay?
Wait, so they want to be 4S.
It is for S1,
Yeah.
3D5. For S1, gun, 3D4 instead of 5. So I took one electron from the S and one electron from the D. Okay, S, since the S has one electron only, it's done. Okay, one electron from
VP. Let's keep it for S.
skipping for S. Yes, yeah. We don't write it. Yeah, we don't write it. Yeah. Okay. So in other words, 3 is 2, 3p6, 3d4. Okay. Okay. So you don't write 4s here. Nothing. Okay, it will be empty. Clear? What shape and bond angle are predicted by whisper theory for H2O? Shape and bond angle. Shape is what?
Trigonal.
Are you sure?
Trigonal plan.
Excellent favor.
Extension.
Meant. We call it V shape as well. Okay. We call it angular. All of them are correct, but mainly we use meant. Okay. The angle is less than 109 exactly, and specifically you can write less than 109.5 degrees or specifically 104.5 specifically. Okay, it's 104.5. Okay, or less than 109, it's accepted. Which of the molecules CO2, H2O, blah blah blah, will be polar? Which one of them will be polar? Yes, H2O is polar, NH3 is polar. That's it.
That's it.
Yes. CO2 is linear. Okay.
Yeah.
Tachyvoir
NH3 has one.
Both
Don't pay me.
are what? Equal. So
Don't pay me.
it's non-polar. This is none. Okay, non-polar. BF3 BF3 is trigonal planar or
Yeah.
planar triangle. The BF3. Since yes.
This.
Yeah, hold on. I will mention this, Muhammad. So BF3 is trigonal planar, okay? Trigonal planar, when the outer atoms are identical, it is what? Non-polar. Any symmetrical shape, with no lone pairs on the central atom
It's non-polar.
non-polar. Tetrahedral, it's a symmetrical shape with all atoms are what? Identical, like CH4, for example, non-polar. Okay. BF3, it's a trigonal planar. It's a symmetrical shape with all outer atoms identical, non-polar. CO2, symmetrical shape with two outer atoms are identical, non-polar. Since there is no lone pairs on the central atom. Okay. Now H2O,
That's what hydrogen.
it's here, right? You have, when you see lone pairs on the central atom, it's polar, without anything. Okay? All right, children? What about NH3?
Polar.
Polar. N, it has lone pair, right? H. Trigonal pyramid, right? Since there's lone pair on the central atom, it is polar. Okay? Yes?
Does he have
Trigonal planar. Sorry, what I said, trigonal pyramid. The NH3 trigonal pyramid. Okay, the CO2 linear, the H2O bent, and the BF3 trigonal planar or planar triangle. Okay, an exothermic reaction is a reaction where heat is
The next tree is what?
trigonal pyramid.
Trigonal pyramid.
Yeah,
Who is different from trigonal planet?
yeah, trigonal pyramid like DF3. I gave you a table has all that.
Oh,
Okay. Exothermic reaction is a reaction where heat is given off. Hold on, given off from a system into the surroundings is lost from the system, or lost from the system into the surrounding. Okay. So any exothermic reaction, the reaction itself gives off energy. Okay. All right. The system itself. A chemical system in which energy cannot flow into or out of a system is described as what?
Closed system.
Isolated.
What's
Uh-huh.
what's
Isolated is the high end of the systems, which means it cannot let energy, neither energy nor matter, Muhammad, neither energy nor matter to leave or to be absorbed.
closed?
While closed, it can leave the energy to be lost or gained. Like this is what? This is what? Closed. No matter can leave. But it was very cold in the morning. Now it is not cold. That means energy lost. So a closed system can let energy to be lost or gained. Okay. While the isolated system cannot let nor energy neither energy nor matter to leave or to be gained. Okay. Like what? Like is this thermos?
Thermos plastic.
No. Thermos.
Thermos isolated. Is
Yes.
isolated.
Yeah.
Put thermos like flask in boiling water for
Like 1 year.
So you're saying that water will not get hot.
That's right.
It won't get cool.
That means there is no absolute isolation. Right?
There's absolute isolation.
There is no absolute insulation or isolation.
But it's still isolation.
It is still, yeah. Okay, this is like isolated system or closed system. Or there is nothing absolute. Like even matter. Like if it's a closed, what does that mean? If it stays like for 100 years, it will keep the same amount of water. No evaporation. No nothing. Nothing absolute in nature.
Based on time.
Actually,
It takes time
you're
to.
not gonna stay there forever. If it's not under any some form of heat or anything.
If there's no air, bro. Or
Yes, like you just keep it at that corner. Once it sticks in forever.
forever. What?
The water. What happens to the water?
Water, if you mean this one, the closed system or
Yeah, closed.
open system?
Bacteria.
Do you think it will stay forever?
It's just still clean, obviously, but like
Plastic.
No. Do you think this water stayed in this bottle forever?
Yeah, no.
For 5 years?
it evaporates.
Without
But you know now, like just there. That's at the class. It still evaporates.
Yeah.
There's no absolute in nature at all.
Or no absolute.
No absolute darkness, no absolute light, no
Just
absolute nothing. Yeah.
even isolated is not absolute.
No. Like you might have a thermos, for example, that keeps your coffee or tea hot for like 2 days. Okay,
Mhm.
3 days
It starts to get.
start to lose heat, right? Chemical system in which energy cannot flow into or out of the system is called, as we said, isolated. In a calorimeter, 1 gram of sample of magnesium is burned to form MgO, and in doing so, this amount of energy are released. What is the heat of combustion in kilojoule per mole? What is the formula that we need to use here?
And
U equals M C. That's the T, right? Hold on. Right. Okay, so we have the Q, and we have we have
Yes,
we have mass. Okay, M. We don't have the T. We need to find the heat of combustion. Okay,
That's what we're finding.
But C is a
hold on.
C is a constant.
Yeah.
Okay.
Kilojoule per mole. Heat of kilojoule per mole. Okay. So hold on. Sorry. The question gives me for 1 gram sample this amount of energy. So this amount of energy is for 1 gram, right? We need to calculate it kilojoule per mole, which means
Converts grams to
grams to moles.
Yes.
Like 1 gram equals how many moles? N equals mass over molar mass, right?
Yeah.
Now, mass of 1 gram over molar mass of magnesium, of MgO. Mg, sorry, 1 gram sample of mass of magnesium. Mg,
Magnesium?
magnesium, yes, magnesium.
Oh, so
1
that's
gram sample of magnesium, 24.08, I believe, right? 24.08.
Is there anyone?
24.31.
Is that correct?
24.31
We said it's just this.
gram per mole. Okay. Okay. So gram with gram. So how many moles? 1 divided by 24.31. 1 divided by 24.31 equals 0.041. Yes. Let me give myself some space here. Mass equals molar mass divided by molar mass. Too fast? Actually, I want to cover as much as I can, Muhammad, to be honest. This is for you, not for myself. I can move slowly, I don't mind. But I don't promise that we will cover that much.
That's the one.
Mole mg. Guys, you know what I'm doing? You know what I am doing? Okay, n number of moles of mg equals 0.41. The 1 gram of mg equals this number of moles. Okay, so the 1 gram, which equals 0.041 mole mg, produces 25.5 kilojoule. Okay, released. Kilojoule released. Okay, now what is the heat of combustion in kilojoule per mole of magnesium?
Finding 25 divided 0.01.
Yeah, so okay, so 25.5 divided by 0.041 equals, so Q equals
621.8.
divided by, this is the equal times 25.5 equals 619.9 kilojoule per mole. Okay. Should I do it easier way? Should I do it easier way? Like, did you copy this? Okay. You joule mole.
How many questions have we got?
1,000, I believe, something like that.
Crazy.
1 gram mg times 24.31 gram 1 mole.
Impossible reality.
25.5
That's what you get. Yeah.
Times.
That was just no good.
No, no, it's a
I used to.
This is per gram times 1
Eh?
gram. 24.31 gram.
I just explain.
1 mole. Times 1 gram.
I don't know what that measures. I mean, yeah.
I don't forget.
So, I mean,
Yeah.
Never mind. Never mind. It doesn't work. Okay. Given the following thermochemical data, what is delta H for the following reaction? So we have two reactions that lead to the overall reaction. C graphite produces C diamond. So what is the delta H for the following reaction? What law is this? What law is this? Yes, this is law. This is law. Yeah. Okay. So what do you think? What should we do? Graphite produces diamond. So graphite still in the reactants here. Diamond should be where? In the product. So we should what? Flip. Let's flip. So this one stays for now as is. The second one flipped. So it becomes CO2 produces what? C diamond, okay. Plus O2, right? Delta H becomes what? 396, okay. So O2, steel graphite.
Mr. Bill, why are you flipping it?
Because we need to get the overall equation.
Okay.
This is law. Flip, multiply, whatever to get the overall equation. So to get the overall equation from these two equations, you should flip the second one, right? So C graphite equals what? Or produces what? C diamond. So we get the final equation. Now in this case, we flip this, add them now together. Plus 2. Just plus 2, right? 396 minus 394. Just 2 kilojoules, right? Yes? Yes. Good. Okay. Next. Draw and name 3 structural isomers of heptane. Should I go over this question? No. No, just structural isomers.
Oh, heptane.
Heptane, 7 carbon atoms with 16 hydrogens, right? Just do it. And name. So like 2, for example, 2-methyl hexane, okay? For the following compound, draw and name the polymer that could be formed from this monomer. Okay. This is the monomer, 3-bromo, 3-chloropropene. This is the monomer, 3-bromo, 3-chloropropene. Okay, guys, please, always, when it comes to polymerization reaction, write the monomer in this way. C double bond C, 2 bonds up, 2 bonds down. Please, I always keep saying that to my students. Most of them, or some of them, they don't follow that, and they write like something strange. Okay, honestly, how to write this formula? Where's the double bond? C double bond C. This part, right? So these two hydrogens on this carbon, one up, one down, right? The other one, it has one hydrogen and all that thing. One hydrogen make it up, for example, or down, it's up to you. And the other part will be C with these three bonds, CLBRH. Okay?
So yeah, just redrawing.
Yes.
And
Read. Okay. If that confuses you, make all this part as what? As X, for example.
Yeah.
It becomes what? C, H up, H down, and the other C has H up and X down. Okay? And rewrite or the X as CLBRH. Okay? CLBR and H. Yes? When you copy it this way, the polymerization is exactly the same, but you need just to do this. And you break the double bond. That's it. See?
and she meant put in
This N,
yeah.
okay, polymerization. All right. Clear? Guys, please, if any me to go over it again and again, please ask me to do that. This the purpose of this review is to remind you with the main ideas, how to deal with some questions, how to deal with some points that you might make mistake. Clear? This one clear? Yes?
Wait, oh.
So always in the polymerization, focus on this part.
Or can X go to the other side?
Yeah. What do you mean other side?
Or is it already free?
No, the other side has two hydrogens.
Okay.
If you want to flip it, like to make the two hydrogens on the left and the, it doesn't matter. Doesn't. Okay. Yes. Arrange the following compounds in order of increasing the boiling point. Let's see. Which one
The second.
has the lowest boiling point? Ethanamine, ethane, or ethane 1 all? Yeah. So ethanol. Which one is the least? Ethanamine number 2, right? Ethane is London forces. Ethanamine has London forces and hydrogen bonding from the type N H. Last one, London forces hydrogen from the type OH. If you write this way, very straightforward, you will get the answer, the mark. Write the 4 quantum numbers for electron in the 4D orbital. Shazam, you're always complaining. I don't know why.
My memory,
It's not kind of memory, I don't memorize all of that. I understand all of that. Write the 4 quantum numbers for electron 4D. Now 4D, N equals what? 4, excellent. L 2, S L equals 0, P L equals 1, D L equals 2, F L equals 3. So L equals 2. M sub L. Or like read this for an electron. So any one of them. Any one of them. So you can write what? Minus 2 to plus 2, any number. If you don't write them all, like this or this or this, it's up to you. If you write 0, it's okay. If you write -1, it's okay. -2, any one of them. Okay? You have how many values in total? You have 5 from -2 to +2, 5 values. Write any one of them. Okay? Okay, 0 as an example. M sub S equals what? Minus?
What question?
Minus half or plus half? Or minus half?
Plus or minus.
Yeah, that doesn't matter.
So basically, why that 0 and not like -2, -1?
It's up to you. I told you any one of them. This is as an example. 0 is an example. You can write, if you want to write -2 or -1 or 0 or up to +1, +2. Okay? It's up to you. But if you write just one value, I'll accept that. What about the 3s? N equals 3. L equals 0. That's right. M sub L equals 0. Only 0. The only value. Okay. MS equals or minus half. Or as Eden said, plus minus half. Okay. Identify the following atom from its electron configuration. Identify means what? What atom is this? What element is this?
You count 10.
No.
10.
No, Eden. No. 10, 20, 30. Zinc.
Zinc.
Yeah, the period table.
Okay.
30.
Because you have to know it.
No.
Okay, each
No memorizing.
so long.
Yes.
So every piece has a different number.
Yeah, absolutely. Yeah. Atomic numbers, like this is specific for, like the atomic number 30 is specific for zinc. 29 to copper. What else? 13 to aluminum and so on. Okay.
So has a charge like an ion. Will it change the configuration?
Absolutely. For example, so if it's okay, if I give you this for example, X plus 1 is 2, 2 is 2, 2p 6. It should be what? What X in this case?
Nitrogen.
This is another example. Sam asked, if it's X plus, this is the electron configuration for X plus. So what is X?
X
Plus means what?
plus.
Oh.
Lost to electron, lost an electron, lost one electron. So originally it was what?
10, 6.
Originally it was 11. Now it's 10 after losing electron. Now it's 11, 10. So it was originally 11, which is what?
Sodium.
Sodium. Excellent. Yeah, so X equals sodium. Right? Yes? Rama, you asked the question. Is that okay? Good.
Yeah, that's like plus.
Yeah, the plus means one electron was lost. Explain why the metals are good electrical conductors and why they are good heat conductors. Because they have free electrons. Free electrons. Okay, this is the mean or the key words. Free electrons. Okay, the free electrons take the or moves the electricity fast. Do you remember when we talked about this? Like the electron enters from this side, another electron leaves from the other side. That's why it is fast. So the free electrons are responsible for that. When 5 kilogram sample of water was in a kettle, temperature increase. Yeah. Now we need to use what? Yes.
Q is supposed to.
Q equals MC delta T. Okay. This is what?
M.
The mass, but it should be what? 5,000 grams.
grams, sorry.
Be careful. Grams, not kilograms. Sample of water has heated until the temperature increases from T1 to 2. How much heat? How much heat means what?
Q.
Q. Water absorbs specific heat capacity. This is what? C.
C.
Can you do it?
Yeah.
Just plug in the numbers and find the Q.
And the unit is.
You have to talk to you about.
Kilojoule. Sorry, in this case, joule.
Joule.
Joule. Depends on, look at the unit of C. 4.19 joule per gram per liter. That's why we converted the kilogram into gram, because the C has gram units. Okay. And the temperature is Celsius because the C has degrees Celsius. Okay. Yes. Okay. Good. You want me to solve this?
So you have to convert.
No.
This. Use of volume before.
Looking for Q. What? How much heat? Heat.
4.1.
Converting.
Are we converting any?
No, just the 5 kilograms because it should be in grams. The unit for C is gram joule per gram degree Celsius. So the unit of the Q should be in joule. The unit of mass should be in gram. The unit of temperature should be in Celsius, not Kelvin, not Fahrenheit. Okay.
C initial.
Yes. T initial or 1, T final or 2. Final minus initial. 2 minus 1 always. Delta T should be always T2 minus T1 or T final minus T initial. Yeah. 90 minus 30. Okay.
Oh, that means times 5,000 and 4.1.
So the value of unit
Should we move on?
Wait.
Should we move on or we spend more time than if we thought? Yeah, look at this. This is the unit.
That's why, and this is way longer. You don't compare it.
Yeah, Daya, do you have a question?
So this was probably 5,000.
You multiply the 5,000 grams
2.1.
times the 4.19 times the delta T, which is 90 minus 30. Yeah, that's
In what units?
the unit,
What units?
last unit, the final unit,
Yeah, what
Joule.
units?
joule.
Joule.
Yeah. Q, how much heat? Joule.
What's in Rami? 5 million. 7 million.
What are you?
Could be joule. Yeah, divide by 1,000 to make it kilojoule pure. Or you can keep it some like scientific notation. Like how much did you get? 6 million.
57 million.
57 million. So
What?
remember, got this. 57 million.
Yes.
57. So 5.7 times 10 to the power of 6 joules. Okay, or 3 kilojoules. Yeah, it could be. Yeah, why not? It's not a big deal. Next, the following property can be measured to determine the rate of reaction.
Reactions. Temperature.
Pressure.
Wait, sorry, did you say the affect temperature?
surface area.
Surface area, nature of reactant.
Determine the rate of reaction.
Determine activation energy.
Concentration, yeah. Rate of reaction depends on what?
Concentration
Yeah, K and concentration of what specifically?
of reactants.
Reactants. Concentration of reactants. Okay. In the reaction, N2 plus 2O2. In the reaction, N2 plus 2O2, 2NO2 produced. If the concentration changes from this to this in 2 minutes, we have delta what? here. Like from 0.45 mole per liter. Mole per liter is unit of what? Molarity. That's right. So the molar concentration, right? So delta change in the concentration equals what? 1.00 minus 0.45. Okay, and delta T equals T time here. Equals what? In 2 minutes. 2 minutes. So in this case, the change or the rate of the reaction is what? Equals what here?
What's the formula?
Oh, exactly.
Exactly.
Sorry, 5.
Changing.
5, right?
Changing
Delta concentration over delta T.
Oh.
Rate, when we say rate of anything, change in something per time, right? Right, guys? Speed or rate of anything, change of something per time. Now here, the change in what in chemical reactions? Is it changing like in distance, like speed and physics? It's change of what? Concentration, the molar concentration. It's given the question, just the molar concentration per time, okay? So in this case, 0.55 divided by 2 minutes. Mole per liter minute.
It's not like that.
How
Up to you.
If you want to change it to second, if it's multiple choice, for example, this is 0.275 mole or molar, if you wish, per minute. Okay. If the question, if it's multiple choice question, for example, and gives you molar per second, then you need to multiply this by 60, right? Right? In this case, it becomes what? Second. So divide by 120 equals 0. Should divide by 120 equals 4.58 times 10 to the power of minus 3 molar per second, or mole per liter second. Okay. You can write it molar per second or mole per liter second. Okay. Yes. When you have something, please ask. Otherwise, I will move on. Okay.
So leaving it like this way is correct.
2.275 mole per liter minute. But if the question gives you like multiple choice and give you the unit mole per liter second, then it should be 4.58. Okay. Which is actually not a factor that controls the rate of a chemical reaction. What things that like controls or affects the rate of a reaction?
Concentration.
Concentration. Catalyst.
Nature of reactant,
Nature of reactants.
pressure.
Temperature.
Surface area. Catalyst. Yeah.
Nature. Choice.
Pressure is no factor.
That affects the rate of reaction. So how about temperature?
Pressure.
Temperature.
Is that not under nature?
We too.
That's something else.
Yes.
Yes, temperature. Yeah. Yes, temperature.
Pressure too.
Temperature. Yes. Pressure. In case all of them are gases, pressure could affect. Yes. If all of them are gases, that's right. Could affect. Okay. So if you know these, anything else won't affect.
Nature of reactant.
Nature of reactant, catalyst, surface area, temperature. You know what? Let's.
It's not. It's not.
Yeah. Anything other than this is not. I will just. You have them? Okay. Remind Remind us, please. Listen to Cindy. Yes, nature,
Chemical nature of reactants, concentration of reactant,
consideration of reactants,
temperature.
temperature, surface area, catalyst. 5. Okay. Pressure, as Chisholm said, if in case like all gases. Okay, could be yes. So other than these 5 or 6 factors, does not affect. Okay. For the reaction represented by the following, calculate delta H using. Now, okay, let's have this on new page. Okay, okay, in this reaction, in this question, we will review finding the delta H of the reaction using the two different methods, which are using the delta H naught formation of reactants and products and the bond energies, right? Okay, let's. Okay. Using bond energies. Okay. First of all, you should what? You should write the Lewis structure. This is the bad part actually, but the worst part actually. CH4. I'm gonna just redraw the Lewis structures. CH4. Okay. Cl2. Two of them, right? Right? And F2.
Family of knowing what.
These are the reactions. These are what? The reactants, right? What about the products? CF2Cl2. The C has 2 fluorine and 2 chlorine. Right? 2HF and 2HCl. Right? Now, 4 times C single bond H, right? 2 times ClCl plus 2 times F, right? Okay. Here, on the other side. 4 times, no, sorry. Yes, 2 times CCl plus 2 times CF, right? Plus 2 times HF plus 2 times HCl, right? Okay, I should cover every single bond in the reactants and every single bond in the products. From the table, you will be, as I said, you'll have this booklet in the exam. So you where's the bond energies? Example. I think it was like a reading or something. Yes, yes. I should write it and I'll fix this and print it out tomorrow for the okay. Here add the average one average. It also says on. Okay. Now, page 8, average bond energies. Here, this is the table, okay? Now, CH 413. Can you find the 4G, please? 413. So 4 times 413, right? plus.
Put the volumes in question. Volume in question.
Two.
I don't think so. I don't think so. It will be in the table. So you have to take them from the table. Find this. 2 times
239.
ClCl is
239.
239 plus
154.
154 for the chlorine.
Yeah.
So now the total, guys, they have calculators. Help me. 4 times 413. Okay, you find them. Let me finish this. Yes, Sandy. Next one.
2 times 389.
339
2 times 485.
plus which one? HF or the
No,
CF?
CF.
CF. Okay. 2 times
485.
485 plus
2 times 565.
565 plus
2 times 427.
427. Okay. Now here. Anyone found the answers? No one?
1652
1652
plus 478
478
plus 308.
308. Okay. Here. Or whatever. Which one here? 778, right? 778.
678.
678.
970 for the next one.
970 plus 11
30.
30 or 13.
30.
Okay, plus 1
Is 854.
854. Now all this minus all this equals delta H reaction. 1652 plus 478 plus 308 equals 2438. Let me know if I made a mistake. 678 plus 970 plus 1130 plus 854 equals 3632. This is minus plus 2438 equals minus 1194 kilojoule. Okay, 119.
Kilojoule units for.
Yes, kilojoule. Yeah, all these the values from the table. If you read top of the table, the unit is kilojoule per mole. Each of them. So the overall will be kilojoule. Okay. This is for using the bond energies, which is actually a little bit. It needs more time and more effort, to be honest, because you have to draw the Lewis structure and to look after every single bond in the formula. Okay, while the delta H naught formation is much easier. You calculate the bond energies of formation of not bond, sorry, the delta H naught formation for all the products minus all the reactants. Okay.
Products minus reactants.
Yes, it will be in the formula sheet here.
The goal is different from the end of the formation.
Yes. Okay. Delta H naught formation product. Look at this, guys. Product minus delta H naught formation reactants. Okay. For the bond energies, reactants minus products. Okay. So it will be in the formula sheet. Yes. All good so far? Okay.
One energy. These are thermal students.
Yes.
Calculate from the bond
No,
energy.
so this is just keeping.
Be very close, not necessarily, not exactly.
The same table.
Okay, not exactly.
Швейните, конечно. Один из капlos из
Okay. Now here for the okay. Now enthalpies of formation. Products first, then minus reactants. Okay. The products we have delta. Okay. Do you find them? Not sure if they are in the table, but the question for sure in the exam, you will have all the values in the table. Do you have CF2Cl2 in the table? Delta H not formation.
Well, these ones are general.
Anyways,
don't need to.
No, do I need to? No. You just take the values from the table. That's it. So you find delta H naught formation for this plus for this plus for this. Okay, times 2.
Times.
Be careful, times 2, because delta HF I have 2 of them. So 2 times delta H
Yeah.
formation for, okay, plus 2 times delta H naught formation for HCl. Okay,
That one.
you add them all together minus you find the CH4, Cl2 and F2. What about Cl2 and F2?
CO2. You find for CO2 then type Q.
Will you find for Cl2 or F2? If you look in the table for Cl2 and F2, will you find something? You won't find them. Why?
Natural occurrence.
Yes.
I didn't know that. I just thought it was only oxygen.
No. Oxygen, hydrogen, fluorine, chlorine, anyone that's in nature already as an elemental or like it's not bonded to any other element. It's available in nature. It's 0. Cl2, Br2, F2, I2, H2, O2.
So you do HCl.
So if you don't find it in the table, just 0. Write it 0. Yeah. Okay. So in this case, only the CH4. So everything in the products together minus CH4. Okay. Can you find them? Calculate them? I'll be right.
Divide it.
So what are you doing?
No, I just got that. Second one, I think. This thing, we think it's going to have something. Yeah, so, but then this one.
So we're finding the alternate. If you understand.
No, yeah.
Enthalpy of formation.
Enthalpy of formation. We're going to start one thing. Then.
Not really.
I think
Yeah, I just told me.
no, I got it. I think I finished. This idea. Right?
I need to try.
So that's. Yeah. I think it's. Oh, yeah, you move up.
Oh, you pay.
Let's one for Monday for us. Change down, calculus.
Wait, tomorrow. How will I see?
Wait, scheme check calculus. I thought calculus was with us. No.
It
Oh,
is.
oh, yes.
It is.
You put the chemistry and calculus, somebody go cry. You even do the amount of work. You know calculus is too costly. Calculus and vectors, they are different. What you consider one. So we use first one for the second one for it's just too costly. I'm doing
Did
it.
you find the value? The answer? It should be very close to 1,149. Was it negative, right?
Students put in money. I'm doing something together.
Okay, I've found for page F,
Mm-hmm.
2 times negative 2,000.
Hold on, let me just. You found it for this HF. The total or 2 times?
Yeah, but not going again.
2 times what? HF. 273, right?
Yeah, the total negative 5.
Why?
Sorry, yeah, the total for that minus 5%.
Hold on. Total for what? For the HF, the 2 times 2 7. So this should be minus.
Yeah, it's minus. It's minus.
Okay. Minus 5, 4, 6. What about the H? Huh?
It's
0.6. Okay. How come? How come?
Just honestly, the first person you read out.
Wait, you already check and standard more than example.
So we used
Yeah, but why? How come 273 0.3? Yeah.
Yes, 3.
Okay. What about the HCl?
or we had this. Don't be a deal after each guy. Yeah.
Yes. What about the HCl? Please quickly. Minus equals minus 184.6. Okay, what about this? Okay, 2F. Okay, 2F2Cl2. Not okay. Did you find it in Google? No? Okay, whatever. Let's suppose this is 2000. Okay, whatever. Okay, now add this to this to this all together. Okay.
Mr. Gulam, where did you get it first? Okay,
Some just the arbitrary number. Okay, arbitrary number. This is not the correct one.
Alright.
Because no. It will be. In this case, it will be in the table. Yes. Okay. If it's not there, for sure. Minus all this minus for the H. Okay. That's it. Okay. Next. That's it. Just okay. The F2, the Cl2 are zeros. Okay. Okay, next question, guys. Next question. Nitric acid gas into can be oxidized, blah blah blah. This is the reaction. Determinant enthalpy for this reaction is what you need. Okay, so this is what? This is law again, right? This is law again. Now, NO2. Do I need to do this?
Wait,
No, actually, no.
No. Honestly, do I need to do this? Just you flip whatever you. Scroll down or up, you mean? Don't tell that you want to retreat it now. No. Okay. Anyway, it's recorded. It's recorded. I'm gonna give you 5 seconds. 1, 2,
This will on now.
3, 4, 5. Okay, so this question is okay, right? You flip, you multiply, whatever you do
Wait, no,
until you get.
Oh, okay. Yeah. Yeah. The final enter the okay. The final.
You can divide.
It's okay.
I can see no,
Third one.
yeah, no, the first one, you won't use the first one.
Yes.
Flip the third one so I can.
Yes, the first one you won't use it.
Flip the third one.
Yes. I'm of that.
Why? Because there is O, right? There is O. There is no other O in other reactions, so
What do
that
you
it will be crossed out, right? So no need to.
What do you mean?
You don't need it. at
So you can
all.
have it and not.
You have extra information,
Really?
not necessarily to use it. Okay.
So.
Yeah. Okay. So the first one,
You ignore is you also ignore.
yes, ignore the whole
Not the whole thing.
everything. Yeah. Okay, you ignore it. Okay. Like I'm giving you, for example, you want to cook something. You have in the kitchen. You have so many spices, and right? Should you use all of them? No, not necessarily. Okay.
Actually,
How to know? I knew that from the O, 2O gas. There is no other O to be cancelled, to be crossed out with it. So it's not used there, this one, okay? So ignore the first one and in O, okay, do you see O3? Okay. Do you see O3 in the overall equation? Chizaram. Do you see O3 in the overall equation? Answer my question. Do you see O3?
So like say this one. Yes. Then who replace this one? This one? Yes.
Do you see O3 in the final, in the overall equation? The answer is no. You don't see O3, right? So O3 should be crossed out since NO is one of the reactants in the overall equation, and it's one of the reactants in the first equation after ignoring this. Okay, this is the first equation, this is the second. So the first equation has NO, one of the reactants, right? But look at the NO in the overall equation. It is 2NO. That means this reaction should be what? Multiplied by 2. O3 is not part of the overall equation. In the first equation, it is one of the reactants. So in the second equation, it should be what? One of the products, so that it will be crossed out. So this should be minus times -1, right? For now, -1. No, yeah, -1, because the first one will be multiplied by 2, 203, 203 on the other side. Yes.
Yeah.
Firstly, you can't, must you only be able to cancel left, right,
They should be, when you cross them out, one on the right and the left, one on the right. The other equation.
Can you cancel reactant to reactant?
Children, think about that. You will add them. All the reactants will be together, all the products will be together. So if there is a product here, which is O2, and one reactant is O2, no need to keep them, right? Cross them out.
Yeah, cross them out.
Yeah.
But if on the two sides cross, the way it is on first product O2 and the bottom product still have O2.
Add them, 2 O2. Add them. I'm saying you need to add them at the end of the I mean, the reactants together, the products together, okay? If there's O2 here, 10 O2 here, 11 O2, okay? So you you need to add them.
Also,
If there's O2 here and O2 here, you cross them out.
I'm not really clear how you decided to cross out the first one.
Because it has O, and there is no O here, and there is no other O to cross it out, to cancel it. Right?
And I said, those two are different. Answer.
Yeah, this is okay. This equation has O.
Yeah.
Okay. And the overall equation has no O gas, just one atomic. Okay. O gas. It has no, yes, because of the lone O, yes. there's lone O here, right? There is no lone O here, and there is no other lone O there in the other equations to cancel it out.
Mhm.
Okay, that's why I say that there is no need for this equation at all. Okay, we don't need it.
I have a question. Can you use that O to cancel like O3?
No. No. O is O, O2 is O2, O3 is O3.
Okay.
This is thing, this is thing, this is different thing. Yes. Lone O, this is what I mean. 2O. Lone O means O, just atomic O, not O2, not O3. Okay? Yes? Done? Next. Next.
Yes.
Try to take pictures before we finish. To be auto, it would work. No, I don't think it would work because
But you will not cancel.
if you keep it, okay, if you keep it, you will have
Because you know you
like extra O2. Yeah, so it won't give you the overall equation. So this equation is or should be cancelled. Okay. Next. For the reaction XY producing Z, following experimental data collected, blah, 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 determine the rate law equation and the value of K. Rate law equation is what? R equals K
bracket
Excellent. So you need to find M, N, and K, right? So if you find these, you're okay. Yes.
Loves. Please, Ibrahim, please drop it to me, please. Please. Don't mean that it's all over. I could even please, you know. Please.
Extra kids, but
Thank you.
we will change.
Okay. Now. Okay. Now, do you want me to go over this question?
No.
No need.
It's fine.
Okay, so you know that. Okay, perfect.
so
Any question about this?
No.
Yes.
yes.
Okay.
The units for K.
K, it depends on the powers, the exponents.
What do you mean?
I'll show you. Okay. Now, take for example, which one we need to take first? One and two. In this case, y is constant, right?
Yeah.
So we will cancel y and we will get the exponent of x, right? Which is m in this case. So from experiment 1 and 2, okay? R1 equals, or R1 over R2, right away. R1 over R2 equals R1 K times x to the power of m y to the power of n, right? Over K x to the power of m y to the power of n. Let's just plug in the numbers. R1 is over R2 equals K over K. They cancel each other anyways, okay? Concentration of X in the first experiment is 2.0 to the power of M. Y 1.0 to the power of N equals or over. For experiment 2, 4.0 to the power of M, 1.0 to the power of N. This cancels this, right? That's why we take experiments that one of the reactants is constant, okay, to cancel it out, to deal with one unknown. In this case, please pay attention to this. Half over 1 is half, right? 1 over 2, right? Yes? I see some faces. What's wrong? Half over 1. It's half, right? 1 over 2. Okay, equals 2 over 4 1/2 to the power of what? Of m. So that means m equals what? 1, right? So m equals 1. Okay. Now take experiments 2 and 3. Experiments 2 and 3. Do the same. You will get 1/0/8 0 equals. Now we know the value of m, so we can like plug in the numbers 4 to the power of 1/4 to the power of 1, or we cancel them. Yeah. So yeah, so we will keep what? Y, which is 1 to the power of n over 2 to the power of n. So in this case, 1/8 equals 1/2 to the power of n. So yeah, what do you think? Hold on. How to think about this mathematically? The 1/8 equals what? 1/2 to the power of what? 3, right?
Oh, that's so important. No.
Yes.
Sorry.
This is math. Don't blame me.
And key.
Yeah, okay, so we found n and m, right? So m equals 1 and n equals 3. Now take any experiment, any one of them. Let's take the first one, for example.
Okay. Well, in this case, what would you okay?
Hold on. Let's find it first. Take the first experiment. You will see now, Chisholm. You will see now. Now, the first experiment, okay, experiment 1. Now, R equals 0.5, right? Equals K, this is what we want to find. Concentration of X, which is 2 to the power of 1. Concentration of Y is 1 to the power of 3, right? Okay. Chisholm,
Yes, sir.
just 2.1 mole per liter to the power of 1, right? Times 1.0, is it? Yeah, 1.0 mole per liter to the power of 3, right? Right?
And what's the rate? What's the unit of the rate?
What's the unit of the rate?
Mole per liter
Second.
Why not?
Mole
I remember.
0.5 mole per liter second. Okay. So now we have the only unknown we have is K, right, Eden? The only unknown
Yes.
we have is K.
Yes, that's one.
K equals. Now multiply 2 times 1 is 2 0.5 divided by 2. Okay.
It's more second.
0.25, right? Now deal with the units. Now K equal the units. K equals mole per liter second. Mole per liter second, right? Divided by mole per liter to the power of 1. Mole per liter to the power of 3 is mole per liter to the power of 4,
Just
right?
like the unit.
Huh?
The power does not affect the unit.
Absolutely. That's how we get the unit. Mole per liter to the power of 1 and mole per liter to the power of 3. Mole per liter to the power of 4. In other words, mole to the power of 4. Liter to the power of 4. Right? So times or divide by. Now mole to the power of 4 per liter to the power of 4. On the other side, we flip them. So it becomes liter to the power of 4. Mole to the power of 4. So mole with the 4 becomes a 3, and 4 becomes a 3, and liter. So it becomes what? Liter to the power of 3 over mole to the power of 3 second.
Sorry, I said.
Like no one confusion with the units. Serious?
Zero.
Zero marks. We don't write.
Does that make you happy? Does that make you happy?
Very good.
Yes, makes us very happy.
No, don't worry about the unit, okay? Unless the question asks you for the unit.
But they always ask what to.
No,
They
no,
always.
no, I'm not asking you, okay? Don't worry. Okay, next question, so that we don't waste time.
This question.
A solution of, guys, I don't blame you, like, a whole course in 2 months is not easy.
I know. So,
You like
A solution of ASBOH has a concentration of this, calculate the pH of the solution. K for BOH is this value. So that means the BOH is what? Weak base. Since it's a weak base, we have to deal with what? Ice stable. If it's strong, you apply it in the pH or POH minus log, consider directly. If it's not,
I didn't know that.
if it's weak,
I know it's strong. It's how do you know?
It's weak because of KB.
Because KB is KB.
Yes.
And if KB was not given it to be strong.
Yes.
No, just do
this is kind of like hints to know that if the base is strong or the acid that's given in the question is strong, if there is no KB, okay, nothing mentioned about KB or KB.
What about if it was acid? If it
It's come like this.
Yes.
then we still use the acid.
Yeah, the ice
Ice
table.
table.
Yes. Okay. Now here, this is actually maybe the worst case scenario, as they say, like to have a weak base and to be asked to calculate the pH. This is the maximum of this topic. Okay, the maximum. So if you are able to deal with this, you're good. Now, ice.
I'll say that.
I don't know.
The concentration of BOH is 0.25. This is nothing. Why? H2O, liquid. I'm not going to take it into consideration at all.
Yes.
Yeah. The C, the change, minus X, the equilibrium, 0.25 minus X. Here, B plus 0,
Plus X plus
plus X plus X,
XX.
XX. KB equals what?
X squared.
X squared over
Before OH minus times B plus
Equals.
over BOH. Okay, now KB is given the question 1.7 times 10 to the power of minus 6 equals. Now OH minus is what?
X.
And B plus.
X.
So we have X squared over 0.25 minus X.
Yeah.
Again, just a little calculations here.
100.
1 is 0.25 divided by 1.7 times 10 to the power of minus 6 equals what?
What's
It's more than 100.
140.
For sure. But I just want to give the number. Minus 6 equals 1,004. No, it's not.
147.
147,058. Much greater than 100. So ignore this X. So it will be 0.25. Okay, guys, if you want just like quick hint, if the KB or KA is like minus 5, minus 4, and up there, minus 4, minus 5, minus 6, ignore the X right away, because it will be because the KB means very little ionization, so the X will be very little amount. Okay, so ignore it. X equals what before we find the value? X equals what again? The concentration of what? Oil minus equals what? 1.7 times 10 to the power of minus 6 times 0.25 equals divide by sorry, not divide, equals square root of the answer equals 6.52 times 10 to the power of minus 4. Okay, mole per liter. This is what the concentration of OH minus. What can I find from the concentration of OH minus? POH, right? Equals minus log the answer equals 3.1819. Okay, so in this case pH equals what? Minus 14 equals 10.81. This is the pH. Okay.
Yeah.
Is that kind of slow?
What's that?
Yeah, last page.
I'm gonna do one properly like this. That's I couldn't know you. Sorry, exactly. Sorry, you're taking for real kid. Because like I got emotion.
Is
I got journey.
basically the pH value.
I got emotion.
Who is that?
I got them.
I
Balance the remix. Oh.
go so like do it like oh, this is someone who is dead. Yes, it is. So what would you?
Like.
You don't want me to fail, right?
Okay, balance in basic medium. Do we need to do it?
No.
I think we're good.
Oh, balance. Yeah, we're good.
We're good. We're good.
Come on, we need to cover it. We're good. We're good.
Yeah. Eden, please explain. No, explain this, the balancing formula, okay?
Okay. Basic something.
Okay, Eden, can you please do it for the students after the class to save time?
So we need to give me
Just $2, okay?
Okay.
No, I'll accept my plus 4 minus.
Per student. Eden, honestly, I can ask them to add like more volunteering hours, please.
Yeah.
Okay, if you spend time, just let me know. Okay.
Me too.
I'm sorry.
I'll spend time. Balance. No, anything after me time, I can help you.
All right.
But before me time.
You want it?
Now I will.
Okay, what about this question? I think it's okay, right? The galvanic cell and yeah.
Yes.
Okay.
We need no, it's not okay actually.
Galvanic cell that has Ag and Zn. So Ag and Zn.
Yeah, how do you know which and which college?
This is the salt bridge. This is
The lower one is the
That's one.
okay.
This one.
Now,
But yeah, we're not told. You only say AG and Z. Get everybody. Just like.
now, which one oxidizes? Which one reduces? Look at the list. You will find the Zn below. So Zn is the oxidation, okay, part. So it should be on the left. So this is Zn and this is Ag. Okay. Always the oxidation on the left, reduction on the right. So this is Zn to the left. This this solution should have Zn2 plus,
And how do you get to plus?
should have Zn2 plus, and the Ag
Yeah, that's
part should have Ag plus. Silver.
How do you know not AgNO3?
NO3 is secret of iron, doesn't matter. NO3, Cl minus, sorry, Br minus, whatever. Any ion, any negative ion, just like to balance, regardless of the salt. I care about the ions, the metals. Okay. So Zn2 plus, Ag plus. In the salt bridge, we have either K plus Cl minus, for example, or K plus NO3 minus, Na plus NO3, NO plus Cl minus. Charles, are you with us?
Yeah.
Sure. So this is the this is the anode. Okay. This is the cathode. Okay.
Yeah.
This is the negatively charged electrode, and this is the positive electrode. Yes. Okay. Now draw and label. We did. Write the cell notation. The cell notation. Once we know that the Zn is the oxidation, I start with it. Zn solid, Zn aqueous, the salt bridge, these two bars, the salt bridge.
Yes.
Then the reduction. Which one reduced?
Ag
Ag plus
plus
Ag plus aqueous Ag solid. This is the cell notation. Okay. What? The format?
like that should be on the left. Jesus should be on the right.
Determine the oxidizing agent. The oxidizing agent, the entity that reduced. Anode on the left. Yeah, always. Anode on the left. Oxidizing agent is the entity or the species that reduced, which is the Ag plus, the one that gained electrons.
Oxidizing agent. It was Zn2 plus.
Give my
But that's the reduction.
When it is agent, the one that forced
Oxidation.
to the other one to oxidize. In this case, reducing agent, the species that forced something else to reduce. Okay, so it is oxidized, right? So the reducing agent, the one that oxidized. Which one that oxidized? Zn solid, not Zn2 plus, and the Ag plus, not the Ag.
Plus. What was
Suppose Zn relates
To,
to
exactly, to oxidize.
oxidation.
and Zn
Always the word agent. The word agent means the opposite of the previous word, which is oxidizing agent. When it's agent, it's not oxidized, it is reduced. Okay.
Oh, Ag plus. Why do you know Ag?
Because the one that reduced is the Ag plus. Reduced means gained electrons. The one that gains electrons is the Ag plus, not the Ag. Okay.
Can you explain it in terms of the
The reactions. Okay, I will. The electrode that will lose mass,
It's Z.
Zn
the electrode that will gain mass, Ag. Okay. Calculate the cell potential. Okay. Now, what is the oxidizing? The half oxidation reaction. Zn produces Zn2 plus 2 electrons. Okay.
and the E notes is
What about the Ag plus?
speech.
Plus
one electron.
plus electron, or one electron, yes, produces what?
Ag.
Ag, right?
So you
From the list, from sorry, say it again.
you flip you want below.
Yes, I flipped the one. Yeah. Yeah, Zn, the one that oxidized. In the list, it is the reduction reaction, right? So E naught equals what?
0.7.
0. Is it negative or positive?
Negative. What flip flip?
It was
It was negative.
negative. Now it should be what? Positive 0.76 volt, right? What about the Ag plus electron? In the list, it is reduction as well. E naught, I think it's 0.8, so right? Positive 0.8 volt. So again, Cesar, this is positive, but in the list is negative. Why? Because in the list it is reduction, not oxidation. Since here it is oxidation, I flip the reaction and I flip the sign also. Now the overall equation is what? This should be multiplied by 2 to make the electrons what? Equal. So Zn plus 2Ag plus produces Zn 2 plus 2Ag. The E naught cell equals what? Add them. 1.6, 1.54, right? Is it? No, 5.6. Right? Volt. Right?
Yes.
Questions? Now, in terms of the equations,
Right regions.
yeah, see,
Zn.
Zn oxidized. So Zn will be the reducing agent for the Ag plus, which forces the Ag plus to reduce because it gave it electrons. Okay, the Zn is giving electrons, right?
Yeah.
Which forces the Ag plus to take these electrons to reduce. So it is the reducing agent,
And Ag.
the forcing agent for Ag plus to reduce.
And Ag plus was Zn2.
Yes. Yes.
Equal.
The Ag plus needs electrons, so that it forced the Zn to give it electrons. Okay. You know what? If they named it or called it like the forcing agent to reduce or the forcing agent to oxidize, I think comes less confusing.
Reducing agent. It's oxidized.
Back here.
It's two. So it's two. Because we multiply through by two. Balance the election.
We didn't multiply. We don't multiply the E.
But we multiply the rest of
No, just the equation. Yes, because it's a quantitative. It's not per mole. In other words, the voltage is not per mole. It's the for the electrode itself, regardless. So,
and you just have to write it back soon after writing
if they calculate the cell potential, no need to write the equations if you want. You just, yeah, I added them together. The oxidation
added.
to find the immuno cell for the total reaction.
No, yeah.
Okay,
I go.
this is
I go. I see question.
the esterification is what? Taking water molecule from alcohol and carboxylic acid, right? Okay. So if you take water molecule, the OH from the carboxylic acid and the H from alcohol, you will get ester. So this is the equation. Salicylic acid, methanol. Take this OH, sorry, this H, and this OH to form the ester.
Oh,
Okay.
yeah, something. That's not positive.
Well, yeah. You can see S. Well, yeah.
I think you did well.
It's already.
Justification.
Top way there. Where is
This is one of the experiments that you wrote in that report. Okay. The top oily layer, the reaction will be the ester. It's the whole like experiment about this. Okay, to synthesize the ester. Complete the chemical reaction. This is that. Okay. I will check just the most. This is what about the nylon. What? Huh? We can't like spend like 5 minutes in each question because we won't continue. No way. No way. So you need to be like as fast as possible. Now the nylon, since synthesis of nylon, is the nylon natural or synthetic polymer? This is one of the experiments that you did as well, or I mean, wrote a lab report about it. Is it natural or synthetic? Nylon. Synthetic. Okay. Where does nylon form with respect to the two layers of the reactants? It will be where?
In the middle.
In the middle.
So you pull it out.
And you pull it out. Yeah. Yes. In the middle. Okay. Complete the chemical. That means you read the experiment and you did the lab report.
Yes.
Yes.
You know what I mean. Okay. I'm not okay. In general, generally speaking, some students they just copy from other students from previous courses, whatever. Whatever. Okay. Where does the nylon? I always say, complete the chemical reaction? It's just kind of what?
That's
I'm not gonna mention names. Okay. Okay. So in this reaction, actually, the Cl. This is actually C double bond O Cl. This part, okay. This part here.
I don't see that in my report.
Okay. This part is C double bond OCl, okay? The other part is, or the other compound is NH2, okay? This part here. And continue there.
You don't talk about it.
Now the H, one of the H's here, NH, right? So this H with this Cl leaves as what? HCl. So we bind the N with the C directly. Okay? Clear?
This again.
I said we can't spend
Not too much.
yeah. And okay, this compound, okay, I will write just C double bond OCl, okay? And this compound, I will flip it this way and make the N from this side, H and H, okay?
Okay.
And the rest of the compound. This H with this Cl leave as HCl. Okay, and N with the C.
Okay.
Find the end.
Yes, C double bond O N.
So this is condensation.
Yes.
ionization.
Yes, yes. Okay, Ahmed?
But like, what's the complete for
What's that?
like ONHCl?
CL,
Sorry.
CL. Okay. Okay, I would write the final answer, okay? I will write the answer in the space here. Since this is polymerization, which means H N
Yeah, so
H. Okay, this is the part. You know what? I'll write it down.
I mean, I think it's assignment.
You put the values of C.
This is the final answer. This is the polymer, okay? This is the polymer. Recording still. Oh,
Why?
It's not even the most like what did. You go through the
not necessarily inside the video.
Yeah, we not it. I'm saying I not sleep it.
It's to be in the video, but I mean, this is how to deal with optimization.
Oh.
So this is what I'm saying.
Don't worry. Don't get angry. This is the last time I've seen that.
I don't want to explain.
So after tomorrow, you don't see us again.
This is the one of the experiments papers. This is the synthesis of nylon. If you go to back to the experiment and read it and watch the video, you will know what I'm talking about. Anyways, this is how you should write the polymer, okay? By taking HCl from between the two monomers, okay? This is heteropolymer. It's not homo. It's not the same monomer. Two different monomers together, okay? Which are repeated. Anyways.
No, I don't.
Three-dimensional structure, bond angle. I think.
Hey,
Like
structural.
you know, we took enough like from these examples, okay?
Are we with midterms?
No, we're not.
Can you give
What's
us
that?
our midterms, please? Do I remember this
No, they're not
question?
allowed to give.
Yeah, this question was in the middle.
Are you allowed to give us our midterm?
Allowed to what?
Give us our midterm.
Oh.
Take a picture.
Oh.
For the midterm.
Didn't you take picture for it?
No.
We have the clip for the midterm.
You have?
No.
Me, I have it, but
Can you just take a picture?
You need the key, like your
I see it.
answer sheet.
I'm
Marking script.
not sure if I will be able to do that today.
You can't be tomorrow.
Okay, I'll do my best, but I don't promise. Okay, I do my best. Okay, what's the why 2 p.m. Yes, the same class time. The same class time. Okay.
So not Friday.
No, not Friday. Not Friday. Tomorrow. Not Friday. Tomorrow.
This is not Friday. Because that's not Friday, nobody will answer it.
Yeah, it's tomorrow. No, I think no, he knows. I'm sure because we talked about this yesterday. Okay, which is easier to burn, a big piece of wood or just easier to cut it in small pieces? Why? Surface area, one of the factors that affect the reaction. N2O4 colorless, NO2 is brown. When we increase, when we heat, if we heat the reaction,
Increase temperature.
Heating the reaction, adding heat to the reactant side, shifting to the left, sorry, to the right. So more brown, right? More brown color, right?
Explain that
We are
again.
increasing
Wait,
it, we are adding more.
Always the equilibrium shifts away from the addition, right? We are adding heat. The heat is on the reactant side, away from the reactant side towards the product side. The product side has NO2, which is brown color. So we are adding more NO2, making the color more darker. Okay? Clear?
Yes.
What about if we add, if we decrease the volume?
Decrease the volume.
Yeah.
The volume. To the right. Right.
Decreasing the volume means increasing the pressure,
Decrease, oh, sorry.
right? Decreasing the volume means
It's increasing.
increasing the pressure. Increasing the pressure, shift the equilibrium towards the side that has lower number of molecules, which is to the left. That means the colorless or the brown color starts to, okay? Some batteries are rechargeable, others not. Explain that.
Because of pressure.
Some batteries, please, guys, listen to this, please. Listen to this. Some batteries are rechargeable. Why? Because rechargeable means what? The reaction is what?
Continue.
Reversible. So one of the products is what? Electrons, electricity. That's why it's battery, right? Battery produces electricity, right?
Yes.
When we add electricity back to the battery, we are shifting the equilibrium to the left to reproduce what? The reactants, right? Right? So when you use the battery, you are actually reacting these together, okay? All right. Yeah. You are reacting these together to produce electricity. This is the thing that you want from the battery.
Yes.
When you recharge it, you flip the reaction. When you add, the equilibrium shifts away from the addition towards reproducing the reactions. So you are recharging the battery means you are reproducing the reactants. Once we get the maximum amount of it, not all of them, the maximum amount, because by time we start losing these amounts. So the maximum amount of reactants, it's fully charged. You unplug the charger, the reaction starts back to the right. To the right means to produce electricity again. Is that clear? Yeah.
So when you're charging the battery, it's shifting it back to the left.
To the left.
To reproduce the reactant.
Yes. Okay, this is how recharging.
Batteries.
What about, okay, others not, means that
It's not reversible, it's just
one way. One way. You can't. If you plug in for example, if you put a non-rechargeable battery to a recharging station, it will do nothing. Why? Because the reaction itself is not reversible. You can't.
Where the electrons move?
They are all going like.
They're all
Nothing happens.
Not
The-
now.
yeah,
I
the
don't read through the battery.
what is that?
The
The reaction is one way, okay? The electrons are producing, okay? If you just plug in the charger to this battery, there's no way to reproduce the reactants again.
Yeah, but see, electron line. Where is it?
No,
There is.
nothing, no. Maybe because there's no this is a good question, but there's no connection between the positive and negative from outside, from inside. Is my point?
Yeah.
Two synthetic polymers, right? Synthesis reaction for only one of them. Polyethylene, polypropylene, polyester, whatever. Okay. Mention two polymers. Just I have to finish like in 5 minutes.
Okay.
Draw Lewis structure for these compounds. You know how to draw that. Okay. Okay. If I ask you how many pi bonds in this compound?
How many pi bonds?
Two. Only two. One of this double bond and one of this double bond. 2 pi bonds. Okay. How many sigma bonds?
One.
Three in your Bible.
One.
Two.
So there are two doubles.
Oh, you're not curious.
How many sigma bonds? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
11.
Yeah.
So 11 sigma, right? This one has only 1 pi, right? How many sigma? 1, 2, 3, 4, 5, 6, 7, 8 with the H, 9, 10, 11, 12, 13. 13 sigma. Okay. 13, okay. What are the values of this and this bond? C, CO, C, CO. This bond is what? This bond angle is what? What's the, you need to know, what's the hybridization of this carbon, right?
Of which
CO, sorry, CCO. This angle is what? It's not 90. Be careful. This is 2D structure. It should be what? Since double bond, this the hybridization is what?
one?
sp2. The bond is what? 120. Okay. Okay. Hold on. This is for sorry, this is for COC. CCO. CCO. This is the bond. And CC, this is 120. And CCO, this one, is what? CCO, this angle is what? No, 109.5. Hybridization to sp3. When the carbon makes 4 bonds, means the hybridization is sp3. The bond should be what? Angle 109.5. Okay. How many bonds? Okay, pi and sigma, we said that. We talked about this, about the collision. About the collision. If you have H2 and Br2, okay, to form HBr, 2HBr. This is the correct way of collision. Okay, if it's like this, it's like this, H and Br, okay, you won't get, okay, this way, sorry, H. If they collide this way, this will collide with the Br, H with the Br. So this H with this Br can't make a bond, right? So this is active or ineffective collision. So the best collision is what? The effective one is this one. Okay. So what to do in this question? How to draw the effective collision is this way. This is Br. Okay, this plus HH plus Br gives H. Look at this, dots to Br, which means new bond is being formed, and H dot with H means what? Broken, is being broken. Okay, and H with Br again and BR with BR. So these bonds are being broken, this one, and this one is being, formed, and these ones I'm done.
Yes. Yes.
This one and this one are being broken, and the yellow ones are being what? Okay.
No, but it's just.
I think almost done. Decomposition, magnesium, equilibrium equation. Equilibrium equation is what? K equilibrium equals
You.
2
over mg.
No.
I miss sorry.
exactly. So you can't write. So ignore this. Over.
Just-
Ignore this.
Just.
So it's the only one. Read B. Explain why MgCO3 and MgO are not included. So if you wrote them in the first part,
You not.
yeah. So because they are solids and their concentrations are constant included in the value of K. Okay, we ignore them because just write ignore them because they are solids. Okay, that's it. Does the following equation represent a redox reaction?
Yes.
Check silicon and silicon here.
Actually, those are.
Silicon is what?
Silicon is.
+4.
How many was they said no with us like. It's not that one, sorry. Like two ions of both like zero.
Yes, but this is the redox reaction, oxidation and reduction. When we combine the oxidation and reduction together, we cross out the electrons. Why? Because one is gaining, one is losing, right?
And then.
But still, it is a redox reaction.
Minus
So.
This is the overall
The noise
after crossing out the electrons.
To.
to zero.
The silicon is +4. Why? Because the Cl is -1 times 4
Minus 4.
-4. So the silicon will be +4. What about the silicon solid?
Zero.
0. From +4 to 0,
Reduce.
Reduction.
decreasing this is reduction, right? Reduction. What about the Mg? It was 0, and here it is +2. So this is what?
Oxidation.
Oxidation. So this is the redox reaction. Okay.
How is the charge difference in the reaction? Product.
What do you mean?
It's +4 here and
Yeah, because it's gained.
the whole thing, not just silicon.
The silicon was +4. It gained electrons from the magnesium.
Yes, but the whole thing was +4 and then here it's +2.
+4.
No.
You mean the magnesium +2?
Magnesium was 2. Silicon is 4.
Yeah.
You mean, okay, one is +4 and one is +2. But look at the magnesium MgCl2. 2 of them. And 2 magnesium. So each magnesium produces or gives 2 electrons, right? So we need 2 of them to give 4 electrons so that the silicon can take these 4 electrons and become silicon neutral.
We multiply it if we add a coefficient.
Yeah, that's why it's 2 Mg solid.
It becomes 4 plus.
No. No. The Mg itself is +2, but I need 2 of them.
We multiply the coefficient by the charge. That's what I mean.
The overall charge.
Yeah.
Yes, the overall charge, yes. But we don't say the oxidation number of magnesium is a +4. Did you get my point?
Yeah.
We can't say that. But the overall charge is 4. That's right. 2 times 2. Okay. I think last question. Thank you. Any questions? Okay, so I'm gonna stop the recording and see you tomorrow.
We will send you to. We will.